are finishing this section today. We now know how to find zeros of polynomials if we can't factor them nicely. We did that in the previous section. What's our strategy? How do we factor
The possible.
Yeah, we did our possible zeros. P's, Q's, possible zeros, and work from there. We learned yesterday some properties about the graph. So we know that the end behavior is based off your leading coefficient. If the degree is even, both ends are pointing the same direction. If it's odd, they're opposite. We know if the negative, or if the coefficient is negative, that flips our end behavior. And we know a few things about the zeros. If they have an even multiplicity, what happens? It bounces. It'll hit the axis and bounce off. If it's an odd multiplicity, it will go through. So today, we're taking all these different pieces that we've been doing and we're going to put them together to draw the graphs of these polynomials. So there's certain steps that I want you to go through. On a test or quiz, you don't have to memorize these steps. I will say part A, factor your polynomial and give the zeros. Part B, tell me if the graph is going to bounce or go through at each of these zeros. So I will tell you exactly what I want from you. So we need it factored if it's not, so that we can give our zeros. We'll look at the multiplicities to decide if we bounce or go through. We'll do the end behavior, y-intercept, and graph it. So let's take a look at this polynomial. I want to graph this one by hand. So it's already factored. So you should be able to tell me all of the zeros of this function. So what makes 2x minus 1 equal 0? What about x plus 1? And x plus 3? Okay. Then the next question I'm going to ask you is, does the graph bounce or go through at each of these zeros? If we don't have a multiplicity written, it's just 1. 1 is an odd number, so what should our graph do? So it will go through every one of those. All right, end behavior. What is my degree if I multiply this all out? We would have a 2x times an x times an x. So we would get a 2x cubed. So it's an odd degree, so it looks like a chair. The coefficient is positive, so it doesn't flip. So my end behavior should be down up. All right, y-intercept. How do you get a y-intercept? So if I make all of my x's 0. Okay, you probably don't need to show this much work, but since you might want to be able to look back in your notes, I'm going to write it out this time. So 2 times 0 minus 1 is negative 1. 0 plus 1 is 1. 0 plus 3 is 3. So negative 1 times 3 is negative 3. And then we are going to graph this. My zeros are my x-intercepts. So I need to hit my x-axis at negative 3, negative 1, and positive 1/2. My y-intercept is negative 3, so I will hit my y-axis at negative 3. Okay, and then the end behavior. I told you it was down up, so this end should be pointing down and this end should be pointing up. The only place you can hit the x or y-axis is where we have a dot. So don't start adding in a bunch of other places. So we're going to start down here. Okay, when I come up, I have to hit my x-axis at this point, and we said it will go through that point. So we're just going to hit it and keep going through. Okay, we have to come back to hit this one. Okay, it was through again. We have to hit our y-intercept. So if you So then we hit the y-intercept, come back, hit our last x-intercept, and go through. Does that match the end behavior we said we needed? Yeah, we have one end going down, the other end pointing up. Double check. Did I hit the x-axis only at the places I said? Yeah, we don't have any extras. We said we would go through all of those, and we did. Now, is my graph perfect? No, I didn't find other exact points. For all I know, the graph went way up here and then came back down. Maybe it dropped down here and came back. I don't know that for sure. What I am looking for on these is, do you hit your axes at the correct points? Do you have the right end behavior? And then you should have a nice smooth curve connecting them. So no sharp corners or zigzags or anything like that. How could you kind of double check? Yeah, you have a graphing calculator, don't you? Why don't you plug this original one in and see if our graph kind of matches what your calculator has. Again, we know it's probably not perfect. The height is probably a little bit off. Is it close? So we can kind of double check our work with that. Your window is just weird. You're welcome. Right. Anyone else have trouble with their calculator showing weird things? All right. Let's try another one. All right. I'm going to ask several other questions along with this one after we draw the graph. I left you lots of space below that one, I think, so we can kind of work out some things. Is this one factored? No. No. Can I factor this?
Yeah.
What could I do? Okay, we can do our P's and Q's in synthetic division. What do we look at for the P values?
Negative 16.
Negative 16. So that would be plus or minus 1, 2, plus or minus 4, plus or minus 8, plus or minus 16. What are the Q values?
Plus or minus 1.
So my possible zeros, P over Q, would just turn out to be these P values, right? Okay, so we're cheating. We're trying to draw a graph, and we're going to use the graph to help us find the graph, but just overlook that. So let's use the graph to find one that works. Otherwise, we're just sitting here plugging in numbers blindly until we find one that equals 0, and we have better things to do with our time. So what's something that makes it equal 0? Negative 2. All right, what do you do once you find a 0 that works? Synthetic. So we'll do synthetic division with the negative 2. What's wrong with my synthetic division the other way?
0.
Yeah, we don't have an x squared term, so make sure you put a 0 in for that. Is this something I can easily factor yet? So what do I do now? Synthetic again. What else can I do synthetic with? 2? Alright. Does that factor nicely? No. So then what do we do? Quadratic. Alright. We're just throwing everything in one problem. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I get 4 minus 16. How would I break down the square root of negative 12? 4 and 3, and since it was a negative, it would get an I. Square root of 4 is 2. So we get 1 plus or minus I radical 3. Now, in terms of graphing, like that is one of the zeros, but is that useful to me? No, why? Can I graph an imaginary zero?
No.
No. Okay, so for us, when I ask for the zeros, okay, my zeros are negative 2, positive 2, and 1 plus or minus I radical 3, but in terms of the graph, we can't actually graph that, so we're just going to kind of ignore it for the graphing purposes. Both of these have a multiplicity of 1, so will the graph bounce or go through? Through both of them. All right, in behavior, look at the original. X to the 4th, what should x to the 4th look like? Like a parabola, both ends pointing up. Y-intercept, if you plug in a 0 for all of your x's, what do we get out? Negative 16. If we do it at the beginning, we see 0, minus 0, plus 0, minus 16. All right. So I hit the x-axis there, y-axis, I'm going to count by 4s. Alright, so we said both ends were supposed to be pointing up. So we're going to start up here. We have to hit our x-intercept when we said we'd go through it. Hit the y-intercept. Come back and hit your other x-intercept when we go through it. So it's something like this. If you look on your graphing calculator, there's an extra little hiccup in the graph. But this is what I will be checking for. Do you have all of your intercepts in the right spot? Did you correctly bounce or go through? Is your end behavior the right way? Sometimes there are faster methods, like P's and Q's, that's kind of time consuming. A lot of the problems I'm going to give you are already factored. Does anyone know? We could have actually factored this. Do you know how? 4 terms. Grouping would have worked here too. But P's and Q's work as well, so we got it. All right, I'm going to ask you a couple questions. Can you tell me by looking at this graph, what are the x-intercepts? Yeah, x-intercept is just another word for 0. We already answered that once. The second question I put on there, where is p of x less than 0? That's asking where is this below the x-axis? Between negative 2 and positive 2. The last question, where is p of x greater than 0? That's asking where is this graph above the x-axis? So I could ask you questions about the graph once we have it. All right. Yes? No, because an x-intercept implies you could plot it on an x-axis and you couldn't plot the imaginary one. Other questions there? We're going to do just a few more, probably not quite as long as that one. If I give you this one, it's not factored, but I also can't do p's and q's. Why? There's no constant. So what could you do? Everything has an x. I'm actually going to take out a negative x, just because I like my leading term to be a positive. Then what could you do?
Easy.
Slip and slide to factor that, yep.
Oh my gosh. No, I'm embarrassed. That's what I meant.
I knew that's what you meant. Alright, so what multiplies to -2 and adds to +1? And then what do you have to do to each of those? So we have 2x minus 1, x plus 1, and we also need that negative x we pulled out. So this is the factored form. Alright, once I factored it, I can do the rest of the stuff. So my zeros. If it's just a plain x, what makes that 0? 2x minus 1, what makes that 0? X plus 1. Alright, will the graph bounce or go through? It's going to go through all of them because they all have a multiplicity of 1. And don't worry, I will do one that doesn't go through here in just a second. In behavior, if I look at the original, negative 2x cubed, what's that in behavior going to be? Up, down. It's odd, so it looks like a chair, but the negative flips it. Y-intercept, if you plug in a 0 for all of your x's, what do you get? 0. Okay, so my zeros are where we hit the x-axis. Hit the y-axis at 0. This end should be pointed up and this end should be pointing down. So if I start up here, hit my x-axis, go through, gotta come back and hit here, go through, come back and hit this one and go through, and we get a graph something like this. And you can always double check this with your calculator and make sure that it does match correctly. Questions? I think I have 2 more left, so we'll do at least one of those. They're both already factored, so they won't be too time consuming. So if I asked for this one, what are my zeros? What makes this equal 0? Remember, your multiplicity comes from your exponent. All right, so at 1, the multiplicity was 2, and 2 is even. So what will happen on my graph? It will bounce. All right, at -2, the multiplicity is 3. 3 is odd, so this one will go through. End behavior. If I multiply this out, we would have an x squared times an x cubed, which gives me x to the 5th. So what should my end behavior look like? Should look like a cube. Y-intercept, if you plug in 0 for all of your x's, we get -1 squared times 2 cubed. So 1 times 8, which is 8. So if we plot everything, hit the x-axis at -2 and +1, y-axis at 8, should start down here and end up here. So I'm starting at the bottom, I come up and I hit my x-axis at -2, and we said at -2 the graph will go through. So it's going to go through that point, we've got to come back, hit our y-intercept, come back and hit the x-axis at 1, but at 1 we said the graph bounces, so it means like we get a turning point here. We touch the axis, but then we turn around and go back the same direction. So it looks something like that. Why don't you guys take a minute on the last one and see if you can run through the list of information. Let's check what you have. The zeros, if it's already factored. When you have an x to the 5th, what makes that 0? 0. But since it was to the 5th power, that means it's multiplicity 5. X to the 5th is like saying you have x multiplied 5 times. So 0 works 5 different times. X minus 3, so that's just 3. And x plus 4 would be a -4 multiplicity of 4. So at 0, will my graph bounce or go through? Through. 5 is odd, so it goes through. What about at 3? Through, multiplicity of 1. And at -4, that one will bounce. All right, end behavior. So if you multiplied this all out, we have an x to the 5th, we have an x, we have an x to the 4th. So all together, it's x to the 10th. It's a positive coefficient, so it looks like normal. Even power means it looks like a parabola, so both ends should be pointing up. What if you got confused on your end behavior and you couldn't figure it out? Look at the graph. Could you graph it on your calculator and double check yourself? Absolutely. Y-intercept. If you plug in 0 for all of these x's, you get 0 times -3 times 4 to the 4th, which is 0. So we hit the x-axis at 0, 3, and -4, y-axis at 0. Both ends should be pointing up. So we're coming from the top. At -4, my graph will bounce. So I'm going to touch the axis, bounce back. I have to come back to hit at 0. Goes through, come back to hit at 3, goes through, and that would be my final graph. All right. Questions on this? So that is it for this section. I want to give you guys some time to work and ask questions. Problem number 30. You will have to do the P's and Q's to factor it, to get your possible zeros, but that should be the only one that requires everything. Okay, the others, you should either just be able to factor out an x or they're already factored.